Hey, this is 4, 6. I divided it into 2 parts. It's completing the square. In day 1, we're going to do completing the square where a is 1, and then in 4, 6b, the next one will look when a is not 1. All right, so completing the square is another way to solve quadratics. But before we get into that, let's look at some of these. So here you can see these are special because they have no x. Right? They have no x. They have x squared, they have constants, but they have no x's, which puts you in a great situation because you can just walk through and solve it step by step, right? Like here I could subtract 10. I'm at 4x squared equals 36. To get rid of that multiply by 4, I would divide by 4 and get 9. To get rid of a square, I square root. Only thing you got to remember is there are 2 square roots of 9. You could do 3, because 3 times 3 is 9, or you can do negative 3, because negative 3 times negative 3 is also 9. So when you don't have an x, you can walk through like this. Like on this next one, you'd add 5 first, so you're at 3x squared equals 30. When you divide by 3, you're at x squared equals 10. To get rid of a square, we would square root. Put it in simplest form. So x equals, let's see, 10. Are there any pairs in 10? 2 times 5, no pairs, so you can't simplify it. But you would have to remember that it could be positive or negative radical 10. All right, so those are nice and pretty when you don't have any x's. So here's the completing the square steps. I'll take you through them in the problems here. You can see we do have x's, so it's not as easy, right? And we did the factoring method, but not everything's factorable. We did the graphing method, but the thing about the graphing method is it can be really ugly if you don't have a calculator, right? Because of those fractions and decimals. So completing the square is one of the methods that always work. So the first thing that you do is you get the x squared and the bx by itself. So instead of getting equal to 0 like the other ones, you want to get c out of the way. So you'd have x squared minus 6x plus, you're going to save a spot for your new c, I call a magical c, and it equals 55. So what we want to do is figure out what number can we put here so that we get a perfect square trinomial, right? A perfect square trinomial is when your factors are the same. So to figure out how you can do this, you always take half of b and you square it. So b is negative 6, so we take half of that and we square the result, right? So half of negative 6 is negative 3. Negative 3 squared is 9. So here magical c is 9. And if I add 9 on the left, I'm going to have to add 9 on the right. Because then this is a perfect square trinomial, right? When I riddle this, you can see I'm going to get x minus 3, x minus 3. So magical c is the creator here of the perfect square trinomial. So then your factors are the same. So instead of writing x minus 3, x minus 3, we'd write x minus 3 squared. Other side, 55 plus 9 would be 64. So then we would solve. To get rid of a square, we square root. So we have x minus 3 equals, the square root of 64 is positive or negative 8. To get x alone, we'd add 3. So x equals 3 plus or minus 8. So you would figure out those two. We're going to have to do 3 plus 8, which is 11. And then 3 minus 8, which is negative 5. There's your 2 solutions. So in completing the square, you find magical c. Magical c creates a perfect square trinomial. You can then use that perfect square trinomial to get factors that are exactly the same. And then since they're the same, you can write them as a square and then square root and solve. All right, let's try again. So you need x squared and bx on one side. So here I got to move the x's over. So I'm going to have x squared minus 12x plus save a c for magical c equals negative 7. Right? So again, we take b, we half it, we square it. So b is negative 12, half it, square it. That's how you find magical c. So half of negative 12 is going to be negative 6. Squared is 36. So magical c is going to be 36. If I add it to the left, I have to add it to the right. So instead of writing it twice, I know it's going to give me a binomial square, right? What multiplies to give you 36 adds to give you negative 12 is going to be negative 6. Shortcut, this number that goes here is always going to be half of b. Always, 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 always. That's the beauty of creating a perfect square trinomial. So half of negative 12 is negative 6. Equals negative 7 plus 36 is 29. Keep going. To get rid of a square, we would square root. So x minus 6 equals positive negative square root of 29. There's no pairs in there, so it's just radical 29. To get x alone, I'm adding 6. So we have 6 plus or minus radical 29. So they want you to leave it as an exact solution. So that is your exact solution. If you wanted to estimate, you could find out the square root of 29, round it. You'd have to round it. And then find two answers that are estimates. They would be rounded. They ask for exact solutions. All right, so here we need x squared and bx. So we have x squared minus 2x plus save a seat for magical c equals 5. Magical c is half of b squared. So b is negative 2. Half it and square it. So half of negative 2 is negative 1. Squared is 1. So I add 1 on the right. I add 1 on the left. So I have x minus 1 squared, because what multiplies to give you 1, adds to give you negative 2, would be negative 1 and negative 1. It's always going to be half of b, so half of negative 2 is negative 1. 5 plus 1 is 6. Let's see, to get rid of a square, we square root. So we're looking at x minus 1 equals positive negative radical 6, because there's no pairs in 6. To get rid of that minus 1, we add 1. So our exact answer is 1 plus or minus radical 6. All right, example 4. I'm looking. I've got to have x squared and bx on one of the sides. So I'm going to have to move that 78. So it'd be x squared minus 19x plus save a seat for magical c equals 8 minus 78 is negative 70. I can already tell this one is not going to be as pretty. The way I can tell that is because b is odd, right? b is odd. And if I'm going to have to half an odd number, it's not going to be an integer. So magical c, I take b, which is negative 19, I half it, and I square it. Well, halving it's not pretty. I end up with 361 over 4. Easy part of that, you can see denominator 2 squared is 4. Negative 19 squared is 361. Oof. So I have to do 361 over 4. Add that on both sides. So same concept, ugly, because you have fractions now. So we'd have x minus 19 over 2 squared, because it's still always going to be half of b inside your binomial there, equals 81 over 4 is what I get when I add the 361 over 4 to negative 70. So now to get rid of a square, I would square root. So I have x minus 19 halves equals positive negative. This ends up being pretty, right? The square root of 81 is 9. The square root of 4 is 2. So then when I solve for x, I've got x equals 19 over 2 plus or minus 9 over 2. So you're going to have both of them, right? So you've got x equals 19 over 2 plus 9 over 2. Well, 19 plus 9 would be 28 over 2, which is 14. And then you have 19 minus 9 would be 10 over 2, which is 5. So you have 14 and 5. So again, not as pretty because of the fractions, but hey, you got a fraction button. All right, number 5. Again, I need x squared and bx on one side. So I'm looking at x squared plus 5x plus save a seat for magical c equals 79. So magical c, I've got b, which is 5, half it, square it. So 5 halves I can't reduce, so 5 squared is 25, 2 squared is 4. So magical c is 25 over 4. So I've got x plus 5 halves squared equals 79 plus 25 over 4 is 341 over 4. Use my calculator to figure that out. So now, to get rid of the square, I would square root. So let's see, I've got x plus 5 halves equals positive negative. Well, easy part, I know the square root of 4 is 2. Square root of 341 doesn't happen. The square root of 341. So then to get x alone, I'm going to subtract over the 5 halves. So I end up at x equals negative 5 halves plus or minus radical 341 over 2. Boom. So that is the pattern for completing the square. In the next lesson, we'll look at what we're going to have to do when a is not equal to 1.